As nuclear power plants continue to provide more and more of the world's energy needs, it becomes crucial that dependable methods be devised to assay and safeguard fissionable materials, especially plutonium. A wide range of analytical devices is under development at the Los Alamos National Laboratory as part of its Nuclear Safeguards Program. Most instruments are of the non-destructive type. They measure radiation or some other physical property of the fissionable material. Automatic analyzers are also being developed to use chemical assay techniques. They can analyze a variety of materials and achieve measurement reliabilities of better than 1%. The first instrument of this type developed at Los Alamos uses spectrophotometry to measure plutonium and uranium with a high degree of selectivity and reliability. The next instrument in the series is known as the Los Alamos Automated Electroanalyzer. The Los Alamos Automated Electroanalyzer is a versatile instrument which uses an electrometric technique to assay plutonium. Three electrodes, a working electrode, a reference electrode, and a counter electrode, are immersed in the test solution. The electrical potential of the working electrode with respect to the reference electrode is kept at a value which will produce a specific oxidation state of the element to be assayed. The current that flows between the counter electrode and the working electrode to produce this oxidation state, whether from a lower or higher one, is proportional to the quantity of the element present. The integrated flow is read in ampere seconds or coulombs. For the determination of plutonium, the number of coulombs needed to oxidize trivalent to tetravalent plutonium is the measure of the quantity of plutonium. In this method, which was developed for use with the automated instrument, the electrolyte is a mixture of 5.5 molar hydrochloric acid and 0.015 molar sulfamic acid. First, the plutonium is reduced to the trivalent state by maintaining a potential of 0.57 volts relative to the calomel reference electrode. The oxidation of trivalent to tetravalent plutonium takes place at 0.68 volts after the addition of phosphate, which selectively complexes tetravalent plutonium and lowers the potential needed. This method provides a very selective determination of plutonium, even in the presence of metallic impurities, including iron, which interferes in nearly all other electrometric methods for determining plutonium. The machine uses a turntable to hold 24 samples. A glass cell is rotated into position, where it is raised against a Teflon support to make an airtight seal. The electrolyte is dispensed. The sample cell is purged with nitrogen and stirring is begun. The reduction electrolysis at 0.57 volts to a 50 microampere endpoint is carried out. Then the phosphate complexant is dispensed. The machine proceeds with the plutonium measurement oxidation electrolysis at 0.68 volts until the current again decreases to 50 microamperes. These electrolytic operations are performed by an automated potentiostat coulometer. The number of coulombs required for each step is measured for each sample. A semi-log plot of electrolysis currents related to elapsed time enables a trained analyst to identify problems if such should occur. When an analysis is complete, the solution is aspirated to a bottle outside the enclosure. A Teflon aspirator tube, which has been driven through a guide to a precise position close to the junction of the cell bottom and the working electrode, aspirates all of the remaining solution, including solution held in the platinum gauze of the electrode itself. 2 subsequent washings and aspirations remove more than 99.99% of the analyzed plutonium sample. The instrument has built-in sensors and interlocks to prevent instrument damage and unsatisfactory analyses. It may shut itself down to await repair or move on to the next sample. The Los Alamos Automated Electroanalyzer represents an important step forward in the vital program to develop dependable nuclear material safeguards. It chemically assays low milligram amounts of plutonium automatically with a dependability of 0.1%. It performs 2 to 3 assays per hour in samples that range in origin from scrap-type material to pure plutonium compounds. The device is compact, trouble-free, and able to function unattended for long periods of time. A sophisticated product of late 20th century technology, designed to cope with the problems of the 21st. Another technological development ready for transfer to the private sector from the Los Alamos National Laboratory.